Let's talk a little bit about interpreting regression coefficients. So let's start with our regular example where we have years of schooling causing people to have higher wages. So that's our typical regression. And let's say we have data on a bunch of people. So each I is indicating a person in the sample. So we have a bunch of people. We have their years of schooling, we have their wage, so we run the regression and we estimate beta 1. How do we interpret beta 1 hat? Beta 1 hat tells us how much the wage increases for, assuming it's positive, which we imagine it is, so how much the wage increases for an additional year of schooling. All right, that's our simplest interpretation of a regression coefficient. And I'll just write school from now on, an additional year of schooling. Now, we've seen the log specification of that, where we have our outcome variable as the log of wages, and we estimate this equation. How do we interpret the beta 1 that happens then? So if you'll recall, we interpret beta 1 hat by saying beta 1 hat times 100 is the percent change in wages for one more year of schooling. One more year of schooling. Right? So that's if we have a log linear specification. What if we have the log specification? How do we interpret beta 1 hat? Well, beta 1 hat we'd interpret as the percent change in wages. Notice I don't say the percent change in log wages, I say the percent change in wages for a 1% increase. We usually think of it as an increase rather than a decrease, right, in school. So what's a 1% increase in school? Well, if our usual schooling is maybe 15 years, is how our schooling measure is measured, a 1% increase in schooling is not very much, right? It's a very small increase in schooling. A 1% increase and remember, 1% increase depends on the level of schooling. So it's a nonlinear specification. So the effect depends. If we wanted to say, if we started with a low level of schooling, a 1% increase would not be a very big amount. If we were thinking about a 1% increase from having 20 years of school, that would be a 0.2 years of schooling increase, whereas a 1% increase from 1 year of schooling would be a 0.01 year of extra schooling. So the amount of schooling that corresponds to 1% varies according to the level of schooling itself, right? So we interpret the coefficient beta 1 as saying this is the beta 1 is the percent change in wages for a 1% increase in school. That's how we interpret that coefficient. We can get more complex regression specifications. For example, we could have schooling interacted with whether the person is a female or not. So we include the dummy variable for female, and we include the interaction of female times school in our regression. Now the coefficient beta 1 times 100 is the percent change in wages for one more year of schooling for men. And beta 1 plus beta 3 times 100 is the percent change in wages for one additional year of schooling for women. So we can have more complex interpretations. The hard ones are, of course, suppose we have the log of the proportion voting for Trump is equal to beta 0 plus beta 1 times the log of, we could have in parentheses an interaction term, the proportion of the population that identifies as white times a dummy variable. Well, let's not have it be a dummy variable. Let's have it be, no, sure, let's have a dummy variable. The dummy variable be older than 50. Right, so that could be what's inside the parenthesis, and the whole thing is we have the log. Now, obviously, we have to have more variables in the equation. If we have those two interacted, we also have to have them the underlying. So we'd have to have the prop of the population that's white plus the this should be a dummy variable for whether if we're at the county, this couldn't be a dummy variable, this older than 50, so it would be the proportion. So the proportion older than 50. So you can see that it's easy to get a complex regression specification that is not going to have an easy interpretation. What's this beta 1? Each one of these would have coefficients, of course. Is not going to be obvious. But usually what we do then is we predict different values of the outcome for different levels of this variable and this variable, which then tell us what this variable is, and then we predict what the outcome is and compare a variety of levels, because just interpreting the coefficient alone doesn't have much meaning.